Okay, these are the examples for Geometry A, Credit 3, Lesson 4.4. Lesson 4.4, we're going to be learning about the Pythagorean theorem. And this is something you probably have heard of, so let's jump into the examples. So the Pythagorean theorem says that in any right triangle, if we take the two legs, and the two legs are the two sides that form this right angle here, if we square them and add them together, it's equal to the hypotenuse squared. So let's take a look at our example here. This is actually for number 1. And so we have our legs are the 21 and the 20 here. So we have 21 squared plus 20 squared equals the hypotenuse, which we're going to represent with x squared. All right, so 21 squared, 21, which of course means 21 times 21, is 441. 20 squared, which means 20 times 20. So let's go ahead and put that up here to remind us what those mean. So 20 squared, 20 times 20 is 400. And now we just need to simplify this here. So we're going to add it up. 441 plus 400 is 841. But keep in mind we're solving for x. So we still need to get rid of this exponent. So remember, the opposite of raising to the second power, sometimes we call that squaring a number, is to take the square root. Over here, the square root and this exponent, the squaring, cancel out. And then the square root of 841 is 29. So the length of our hypotenuse here would be 29. All right, let's take a look at another example. Very similar. Just we have the triangle oriented differently here. So we have the two legs given once again are lengths of 9 centimeters and 40 centimeters. And so we'll set it up the same way. 9 squared plus 40 squared equals a hypotenuse, which once again we're representing with x squared. 9 squared, 9 times 9 is 81. 40 squared, 40 times 40 is 1,600. And now we're going to simplify. We're going to add up here. 81 plus 1,600 is 1,681. And then once again, we have x squared here. So the opposite of squaring is to take the square root and the exponent cancel out. And then on the left side, the square root of 1,681 is 41. So the length of our hypotenuse is 41 centimeters. And over here, I guess we should indicate that the unit there, of course, in our measurement, which was meters. All right, so again, our answer to example for number 2, 41 centimeters. All right, so now let's jump into an example for number 3. And we're still going to be using the Pythagorean theorem. However, we're going to be asked to find a little bit more information. So here's our example for number 3. And let's go ahead and set that up. We have triangle A, B, C, and D. And this is going to be 7. The whole thing, AC down here, is 48. And that what they want us to find here is the length of AB. Is that correct? Yes, that is correct. All right, so how are we going to approach this? Now, we have two triangles here, two right triangles here. And let's go ahead and indicate this. And we know that, so if we have a right triangle here, this one has to be a right triangle because together they form that straight line or straight angle. And since a straight angle measures 180 degrees, we have 90 plus 90. We can confirm that is 180 degrees, so that checks out. Now, what triangle are we looking at here? Let's actually put the 7 over here. We're actually going to be focused on this right triangle here because we're finding the length of AB. Now, also, what's marked, and this will be the same thing on problem 3, these two lengths. Although it may not quite look like these are equal, but we're going to pretend that they're equal. These tick marks tell us that. And so that AD is congruent to DC. So if we know that, we know the length of the whole side from A to C is 48, to find the length of either one of these, AD or DC, we can just take that 48, divide it by 2, and that tells us that this here is 24. Now we know the lengths of both of the legs here, and so once again, we can just apply the Pythagorean theorem to find our answer. So once again, leg squared plus the other leg squared. And notice it doesn't matter. So as long as I have the legs on one side of the equal sign here, it doesn't matter if I go 7 and 24 or 24 and 7. It's the same. It's going to work out the same either way, because notice it says leg squared plus leg squared. So it doesn't matter which leg that's here, in which order you put them. What's important is that the hypotenuse, which once again is x, is on the other side of the equal sign. All right, so 7 squared, which means 7 times 7 is 49. 24 squared, which is 24 times 24, is 576. And equals, of course, we just bring down our x squared. Let's make this a little bit neater here. All right, so now we're going to add that up. 49 plus 576 gives us 625. Again, bringing down our x squared. And then again, we have the exponent of 2, so we take the square root of both sides. We have x, and then the square root of 625 is 25, because 25 times 25 is 625. Of course, you can use your calculator or even Desmos to find that answer. Just on Desmos, you'll pull up the keyboard and you'll look for the square root symbol, which I believe is towards the bottom. All right, so that is it for an example for number 3 for solving for x. And that, I believe, is all we have to do there, right? Yes, that is it. Just double checking here. Yeah, that is it. All right, so let's go ahead and take a look at an example for number 4. On number 4, we're going to be asked to do just a little bit more work. One step more, not too much, not too much more, not too bad, right? Okay, so here we go. Let's take a look at an example now for number 4. This is going to look a lot like number 3, but there's an important difference, and we'll point that out. All right, so let's go ahead and draw our triangle up here. And let's go ahead and we're going to label it with the same letters. And this is going to be 12. This is going to be 37. And this here is what we're trying to figure out. So, and once again, these are marked as equal. Okay, so a couple of things that are different. This time, we're not given the length of yx. In fact, that's what we're trying to find here. And so, this is also a right triangle here. So the triangle that we're going to be focused on here, this time is going to be the one on the right, because that's what we have measurements for. And the other important difference here, and let's use A here to represent this length here from Z to X. So what's different on this one from problems 1, 2, and 3 is that in this case, we're not solving for the hypotenuse, we're solving for one of the legs. So let's go ahead and set that up. We have one leg is 12, so 12 squared. The other leg is represented by the A, so A squared, is equal to the hypotenuse, which is the 37 squared. So notice this time our variable, this time we're using A, so we don't confuse it with this angle here, is on the left side here, and that's because we're trying to solve for one of the legs. And once again, you could have set this up as A squared plus 12 squared. As long as you have the legs on one side, it'll work fine. 12 squared, 12 times 12 is 144. We're going to bring down the A squared. And then 37 squared, which is 37 times 37, is 1,369. So now in this case, we need to get A by itself. We need to get rid of this 144, and we need to get rid of the exponent. But we'll start by getting rid of the 144. We're going to subtract that to both sides. Of course, the 144s cancel. 1,369 minus 144 is 1,225. Just double checking, making sure that's right. And then our final step here, we need to get rid of the exponent. So we take the square root of both sides. The square root and the exponent of 2 squaring cancel out. And then the square root of 1,225 is 35. Excuse me. So A is 35. Now, remember, they asked us to find yx. So how are we going to do that? Well, remember, these two lengths, yz and zx, so here's yz and here's zx, they're marked as congruent. So if we know one, we know the other. So if this is 35, then so is this. And remember something, this goes back, I believe, to credit 1, the segment addition postulate that says if we have a larger segment, in this case YZ, that is broken down into 2 smaller segments, we can find the length of the larger segment by just simply adding up the lengths of the smaller segments. So YX equals, well, let's go ahead and write it out, YZ plus ZX. And of course, both of those, YZ and ZX, are both 35. And then 35 plus 35 is 70. And so our answer, yx, is what we're being asked to find, is 70. Sometimes we get the question like, well, what's the answer? Is it 35 or is it 70? Well, the answer is 70 because we were asked to find the length of yx. However, we did need to solve for a in order to be able to, a, which represented this leg here, in order to do that. So in a sense, we have 2 answers, but the thing that we were asked to find, the yx, is our final answer, and that is 70. All right, so that is it for the examples for lesson 4.4. Just double checking here. So as always, pause, rewind as needed, and I'm sure you'll do great with these problems. If you have any questions, of course, let us know. And that is it for lesson 4.4. We'll see you in the next video. Until then, take care and God bless.